Alright, so this is day 6, properties of exponents. This is a lesson of basic skills that you should already know. These properties you learned way back in pre-algebra. And so I want to make sure you got all the basic skills down before we start jumping into to the deep water again with Algebra 2 stuff, okay? So the objective is up here, so let's all read it out loud so that you know what you're expected to do. Ready? And begin. I will know the properties of an exponent. Excellent, okay? Good. So we want to review those properties. So we're going to make this, these are the steps actually. If you're on the video, pause here. If you're in my class, you already have them written down. They're up here. So again, they identify the exponents in an expression, identify the strategy and exponential property, and then apply the strategy from smaller terms to larger terms. So we're going to take some notes now in this thing. This is a Frere model. Usually you would draw this in your notebook, but today I'm going to pass it out to you. We're going to go through each of these properties. We're going to write these down. Usually you can write this in your notebook, but today I have it. Again, I'm passing it down to you. So the first one's product property, and these are all exponential properties. So one of them is a product property, so it's at the top left. You're going to watch me do a box and just and then we'll describe it to one another and write it down. Okay, so just watch right now. Product property. Let's say we had a problem like this. It said x cubed times x squared, right? The answer is going to be x cubed plus 2. We're going to add the exponents together. So when we have the same bases, we add the exponents together, and it's going to be x to the 5th. But I don't want you to write that down. I want you to know why. I want you to know why this works, okay? Why does this work? So, well, let's take x cubed. Would you all agree? Eyes up here, no writing, pencils down. Would you all agree that x cubed is like saying x times x times x? Right? And then if we bring down x squared, it's just like saying x times x. Right? So then all we're really doing is multiplying x times x times x times x times x times x, which is x to the 5th, right? But instead of working out the problem all the way, couldn't we just add the exponents together and still get the same answer? So we use the shortcut, or we use the property, because we know that if we were to write it out, it would take a long time. We could just add the exponents together since they have the same base. Does that make sense? So here's an example. I'm going to give you an example just of this working out. Let's say we had a cubed b squared times a to the 4th b to the 1st. What's the answer? Well, you take your a's. They have the same base. We're going to have a cubed times a to the 4th, which is a to the 7th. And then we have b squared times b to the 1st is b cubed. Okay? Easy, right? Any questions on on the product property? Okay, so what I'd like you to do, let's have ones in the groups. Ones, raise your hand today. Ones, all of my ones. So Dalla, raise your hand. Ones, raise your hand. Ones are talking about how does the product property work and what's the rule. Tell the rest of your group. Ready, set, go. David, you talking? You're one. You already explained it? Man, that was fast. You're quick. Okay. Okay, write this down, please. Okay, so predict if the product property adds the exponents when they're multiplied together. What do you think the quotient property is going to do? Subtract the exponents. Watch this, okay? Eyes up here. Quotient property, very similar to product property. It's a little bit different. Let's say you had a problem, instead of two exponents or two terms with the same base, different exponents being multiplied, you have them divided. You see? This is divided, this is multiplied. What do? Here we added the exponents together because they have the same base. Here we're going to subtract them. So the rule is, when you have it like that, you just take x to the 4th and subtract 2 from it, and you get x squared. That's the shortcut, okay? You need to know why, though, okay? So why does this work? Well, just like before, it's just like saying, we know that x divided by x is? Nope. Anything divided by itself is 1. X divided by x is 1, right? And I could look at it this way, long ways, or I could look at it like a fraction. X divided by x is equal to 1, right? Do y'all agree? Okay, so if I were to take my original problem, eyes up here, pencils down. If I take my original problem and I rewrote it like this, x to the 4th, instead of x times, or x to the 4th, I'd rewrite it as x times itself 4 times, divided by x squared, which is just x times x, right? I could cancel these out because I know x divided by x is 1, so x divided by x is going to be 1, right? Each of these. And I could do that again here. There's nothing else I could do in my numerator, so all I'm left with in my numerator is 1 times, times x, which is going to be equal to x squared, or x times x. The denominator is 1 times 1, which is 1. And I could simplify that's x squared over 1, or it's just x squared. Does that make sense? This is a lot of work, right? Does this look like a lot of work? So we need to know why we do this, but the shortcut or the property lets us subtract the exponents. Okay? 2's in each group. Raise your hand if you're a 2. 2's, good. Okay, 2's are talking about quotient property. No one's writing this down. 2's, I want you to explain how it works. Ready, set, go. Continuing on here. So power property says this. If we have like x cubed, okay? Eyes up here right now. If you have x cubed, right, and we raise it to another power, again, x cubed raised to the third, what do? We don't cancel. Watch this. It's just like us saying, would you agree that x cubed to the third is like saying x cubed times x cubed times x cubed? Do you all see that?
Yeah.
Good. How does this relate to the first one? Don't we have the same bases here?
Yeah.
Don't we have exponents that are being multiplied together?
Yeah.
So we add them. What's 3 plus 3 plus 3?
9.
9. Not 6, 9. Okay? So what's the rule? What do? We multiply these together. The exponent with the power. Okay? That's the rule. That's the trick. But this is why. But you don't have to do all this work. You just need to know how to do it. Okay? So, 3's, raise your hand. 3's. Okay, 3's are talking. Now you're all allowed to talk and to write this down. Ready, set, go. Okay? So I noticed that we're starting to see patterns here. As you're writing this down, this first box, or actually this last box, power property, you notice we multiply the exponents, right? Multiply. Multiply the exponents. That's the trick here on the third one. That's the shortcut. On the first one, we add the exponents.
Subtract.
What do you subtract? It just said add. Add the exponents.
No, it was
Okay, and the second one was we subtract.
subtract.
I know, I said that just now.
Subtract.
Okay? I'll just put subtract, okay? So we're getting a little bit of a pattern here, right? Now the last one, or actually I'll give you 30 more seconds to catch up here. Okay, a to the 0. Whenever you see anything to the 0 power, it's equal to 1. Okay, so anything to the 0 power is equal to 1. So why does that work? Let me show you why first. Don't write anything. Eyes up here. So we kind of already dealt with this, but anything to the 0 power is equal to 1 because, let's say we had x squared divided by x squared. That's just like saying x times x or x divided by x squared. Anything divided by itself is 1, right? Isn't x squared divided by x squared equal to x is equal to x to the 0 power? Yeah, because it cancels out. So we make the assumption that when we have x squared divided by x squared, it's equal to 1. But when we subtract the exponents, we get x is equal to 0, which makes it equal to 1. Okay? Cupcakes, right? So let's have Forrest tell everyone else in their groups why this works. Okay? Ready, set, go. Usually we sketch this this in our notebooks, but if you, I'd like you to put it in your notebook. You could 3-hole punch it, or you could cut it out and tape it in, or copy it in.
Do we write this now?
Okay?
Would you like us to write this down?
You were supposed to be, yeah. I handed one out.
Still talking?
Oh, this last box, you want to... Okay, you should have been writing it down. I'll give you another 30 seconds. That's okay. Okay, so we have to keep going here. So this is going in your notes. So now we're going to actually do the lesson. So we're going to apply some of these. This lesson is going to take 2 days. Today we're going to do easier ones, and then tomorrow we'll look at more advanced ones. And again, this is like a pre-algebra, Algebra 1 thing. You saw this, I know, in pre-algebra. You saw this definitely in Algebra 1. And now we're seeing it again because we have to know this before we move on. Okay? Okay, so now I'm going to teach you two of these. We got a to the 5th times 4a to the 6th times a squared. So the first thing I want to do whenever I do any of these, eyes up here so you don't miss a beat, okay? I don't want you to miss like any steps. I want to first think about my coefficients always. So the coefficient in front of here is, no, what's the number in front of a? Good, 1, okay? And I know there's a 1 here too. Okay? So we got 1 times 4 times 1 is 4. I know those are all coefficients. Okay? I want to deal with those first to get them out of the way. Then I look for common variables, okay? My variable here is a. So we got a to the 5th times a to the 6th times a squared. So a to the 5th times a to the 6th times a squared. That's my product property of exponents. So 5 plus 6 plus 2 is 11, right?
What?
13. Just making sure you're awake. I wrote it down right. 13. Okay? Okay? 4a to the 13th power is the answer. Okay? And that's it. You're all done. So again, what did I do? I just took my time. I looked at my coefficients first. Okay?
You did the math.
Then we have our common bases of a. So then we want to combine the exponents by adding them together because they're being multiplied. Each term is being multiplied. So then we got 4a to the 13th. Okay? Number 2. This one's a little bit more difficult. Over here in the numerator, I'm putting a 1 in for a coefficient because there was nothing there, so I'm going to put in a 1 there. Okay? Deal with my coefficients first. Can I simplify 1 over 3? No, I can't, so I'm going to bring that down as in my answer. Pencils down right now. Everyone should be watching right now. Everyone's off today. I don't know what's going on. Okay, so this 1/3 we can't simplify anymore. So I'm going to keep it here in my answer, okay? Then I want to look at my letters, my terms, one term at a time, x, y, z. Let's focus on my x's. Over here I got x to the 1st because there's nothing there. I know that there should be a 1 there. And over here I have x squared. The way you simplify this, we use the quotient property. So we've got x to the 1st and x squared. X to the 1st I could cancel out, leaving just x to the 1st and take 1 out of the bottom. Okay? Then we got y's. We have y to the 1st in the numerator. I could take out 1 y to the 1st in the numerator, and I could take out 1 from the denominator. 6 minus 1 is 5. So we got y to the 5th. Then we got z to the 4th over z to the 5th. I could take out 4 or z to the 4th in the numerator and take out 4 of them in the denominator, leaving just z to the 1st. Okay? Simplify, make it look a little nicer. We got 1 over 3x cubed, or 3x y cubed z. Okay? And that's it. That's numbers 1 and 2. Alright? It does look easy when I do it, but when I have students do these, they get confused. So, before we work, let's have 4s tell the 1s and 2s how to do numbers 1 and 2. Okay, 4s are talking about numbers 1 and 2 to their groups. Ready, set, go. So this is supposed to be y to the 6th, and then that's a 5, y to the 5th there. Not a 3. Z to the 1st. Okay, so then this is y, not to the 3rd. It's supposed to be 5 here. Does that look better?
Yeah.
Okay, sorry about that. My 3s and 5s look similar. My bad. Check your floors if they've fallen. Okay, so here we go. Number 3. Let's write this down, please. Okay, so number 3, we got 2n to the 6 times n cubed. Let's look at our coefficients first. We got a 2 here in the front. And then on the second term, what coefficient's there? 1. So what's 2 times 1? Good. So write your answer down. I'll let you finish this one up on your own. 15. So that's the answer to 3. Okay, those are the answers to 3 and 4. Once you've talked about it, you could clean up your boards. One, number 5.
But wait.
Number 5. That's right. If you do your work now and stop talking, you will leave on time.
And without homework.
No, that would be incorrect because you have homework.
No, I don't.
The coefficients, like 4 and 6, do not apply the exponent properties. Let's pretend this is back like in the day. Can you simplify 4/6? Yes or no? Good. Okay, so 2/3, and then worry about the rest of the problem. Okay, b cubed over b. Look at that big square sheet I gave you. That should help you. Here we go. Answers up. Don't erase your boards. Eyes up here. Check your work. Ready? You should have simplified 4/6 becomes 2/3. Bring that down. Okay, and then the b cubed and the b squared turns into that. So your answer is going to be 2b squared over 3. If you made a mistake, compare your work. Do not erase your boards. Talk about it first. And if you got it right, say, I got it right. Okay? Okay? Don't erase your boards. Talk about it. Number 6. So much sass in this class. Okay. Alright, sassy is not bad. Okay, so eyes up here. Number 6. Quiet. Everyone's working. Go. Okay, so the 6 and the 3 becomes 2/1. I'll bring that down. And then I start alphabetical order. I got m squared on the bottom. I cross that out because it's smaller. Those all go away. And I'm just going to take 2 from the top. 6 minus 2 is 4. So we got m to the 4th left in the numerator. Then I got n's. There aren't any n's in the numerator, but in the denominator I get an n to the 4th. I can't really do anything with that, so it's just left there. So I'm just going to bring it down. N to the 4th in the denominator. And then the p's, I got p to the 4th in the numerator, p to the 5th in the denominator. I'm going to take 1 down. And then I'm going to write it down in, in alphabetical order. And then I'm done. Your answer should have been there. Don't erase your boards. Talk to your neighbors. Where did you make mistakes? Where did you, or if you did, okay? That concludes the lesson.